Alright guys, welcome to this page of the notes, and what we're going to do here is we're just going to start to work our way through the different kinds of problems you're going to run into when using the quadratic formula. And the first one we're going to take a look at is getting two rational roots. So here's the way it's going to work. If b squared minus 4ac comes out to be a positive perfect square, then the equation will have two rational roots or solutions. And let's take a look at how this is going to go. I got a couple of example problems for us here, so let's just go ahead and get this set up. Remember, I like to, it's got to be equal to 0. I need ax squared plus bx is equal to, ax squared plus bx plus c is equal to 0. So I need this 11 to be over here. So we'll just subtract it to the other side. And I will have x squared minus 10x minus 11 is equal to 0. And that is now in the ax squared plus bx plus c is equal to 0. It's in standard form, where a is 1, b is a negative 10, c is a negative 11. So we go ahead and plug that stuff into our quadratic formula. X is equal to a negative 10, all divided by 2, plus or minus a negative 10 squared minus 4 times a times c, take the square root of that, all over 2. All right. Well, let's see what happens. Negative times negative is going to be a positive, and 10 divided by 2 would be 5. Plus or minus. Okay, so then I wind up with a 10 squared minus, 10 squared is 100. 100 minus 4 times a negative 11 would be negative 44, but a negative of a negative would be a positive 44, so you wind up with 144. So the square root of 144 all over 2. But 144 is a perfect square. It's 12. So we wind up with x equals 5 plus or minus the square root of 144, which is 12. So 12 over 2, which is actually 6. And so my two answers are 5 plus 6, which would be 11, and 5 minus 6. That's a terrible minus sign. Hold up. Which is a negative 1. Quadratic formula. Let's try another one. Okay, I got to make sure that it is in standard form, which means I'm going to need to rewrite it first. I'm going to have an x squared plus 6x minus 16 is equal to 0. That is now in ax squared plus bx plus c is equal to 0, where a is equal to 1, b is equal to 6, and c is a minus 16. Plug and chug, guys, plug and chug. X is equal to a negative 6 over 2, plus or minus 6 squared minus 4 times 1 times a negative 16 all over 2. It's going to give me a minus 3 plus or minus, let's see here, 6 squared is 36, and negative 4 times a negative 16 would be 64. 64 and 36 would be 100, so we wind up with the square root of 100 over 2, but 100 is a perfect square. It's 10. And 10 divided by 2 is 5. So we get two answers, which you will always get two answers when it's quadratic. Negative 3 plus 5, which is going to be a positive 2, and negative 3 minus 5, which would be a minus 8. Awesome. One more for you. Okay. Oh, this one is actually already in standard form. I have ax squared plus bx plus c is equal to 0, where my a is equal to 2, my b is equal to 25, and my c is equal to 33. Plug and chug. X is equal to a negative 25 divided by, careful, it's 2a, but my a is a 2, so it'll be 2 times 2, which is 4. Plus or minus 25 squared minus 4 times a, which is 2, times c, which is 33, square root of all of that, all divided again by 4. We wind up with x is equal to minus 25 fourths. Plus or minus, you wind up with the square root of 361 all over 4. And actually 361 turns out to be a perfect square. It's 19. Not one I expect you to know. Please use your calculator. Well, let's get our two answers. Since I have common denominators, I would have a negative 25. Negative 25 plus, negative 25 plus 19 would be a negative 6 over 4, which is going to reduce to negative 3/2, so that's 1. And then I would have a negative 25 minus 19, which would be a negative 44, divided by 4, which is going to come out to a negative 11. And so we wind up with our two solutions. And guys, that takes care of using the quadratic formula. If you wind up with your b squared minus 4ac turning out to be something that's a perfect square, right? You're going to wind up with two rational solutions. Nice numbers, right? The kinds of answers that we really like. Head on over to the next page of notes and we'll take a look at the next possibility when it comes to quadratic formula. I'll meet you over there.